One of the biggest questions we ever ask is, are we alone out there? Well, what if I told you the answer might not be found by looking up at the stars, but by looking deep, deep down inside a cave right here on Earth? It's a wild story that starts in total darkness and, believe it or not, ends up in the cosmos.
Just listen to this. Cave biologist Hazel Barton said, "The wall was bright green. It was the most iridescent green you'd ever seen, and yet the microbes were living in complete darkness." I mean, that's the moment this whole puzzle starts. We're talking about something bright green, which screams life, in a place where there's supposedly no light. It just shouldn't be possible.
So, yeah, how is this possible? Seriously, green means photosynthesis, right? It means life using sunlight for food. But these things were found in a place defined by absolute, total, crushing darkness. It's a total paradox, and figuring it out could literally rewrite the book on where we look for life.
All right, so let's dive into our first section, Life in Total Darkness. We're heading deep beneath New Mexico to see what's really going on with this baffling discovery. So picture this. It's 2018. Two scientists, Hazel Barton and Lars Barent, are exploring Carlsbad Cavern. But they're way, way off the tourist path. They go around this one corner into an alcove that is so pitch black, you literally can't see your own hand in front of your face. It's that dark. And then, one of them shines a flashlight on the cave wall.
And what they saw was this glowing green wall. A whole blanket of it. After they took samples, the test came back and it was cyanobacteria. Now you might know these as blue-green algae. They're basically tiny, single-celled organisms that do exactly what plants do. They use sunlight to make food, photosynthesis. So finding them here, it's like finding a polar bear in the Sahara. It just makes absolutely no sense.
Okay, so this brings us to the big reveal. How do we solve the mystery of photosynthesis happening in the dark? Well, it turns out these little guys weren't breaking the rules of physics. Not at all. They were just playing a completely different game, using a kind of light that's totally invisible to you and me.
And this is where it gets super cool. You know how most plants on the surface use a chemical called chlorophyll A to soak up sunlight? Well, these cave microbes, they've basically hacked the system. Over time, they evolved to use these special versions called chlorophyll D and F, and these are tuned to grab energy from a totally different part of the light spectrum.
The energy source they're using is something called near-infrared light. Now this stuff is all around us, but its wavelength is just a little too long for our eyes to pick up. That's why the cave looks completely, utterly black to us. But for these microbes, it's not dark at all. They're bathing in a type of light we can't even perceive.
And I love this analogy from Hazel Barton. She says, to near-infrared light, caves are pretty much a hall of mirrors. Think about that. The limestone walls of the cave, they soak up the visible light pretty quickly. But for this invisible, near-infrared light, those same walls act like a bunch of mirrors, just bouncing it and reflecting it deeper and deeper and deeper into the cave.
And here's the kicker. This is the proof. When they actually measured the light levels, they found that in those super deep, super dark parts of the cave, the near-infrared light was, get this, almost 700 times more concentrated than it was at the cave entrance. And wouldn't you know it, that's exactly where they found the thickest patches of the green microbes. They were living right where their food source was the strongest.
Okay, so cool story about some weird microbes, right? But this is where things get really mind-blowing. We're about to go from a tiny discovery in a New Mexico cave to the entire cosmos. Because this changes everything about how we search for alien life.
See, here's the thing. Most of the stars in our galaxy are not like our sun. Not even close. The vast majority of them are what we call red dwarfs. And guess what kind of light they pump out more than anything else? Yep, near-infrared light. The exact same kind of light that's powering those little green microbes deep underground.
Now, for years and years, whenever scientists looked for life out there, they focused on what's called the Goldilocks zone. You've probably heard of it. It's that sweet spot around a star where it's not too hot, not too cold, but just right for liquid water to exist. That's been our main playbook.
But these little cave dwellers just tore a page out of that playbook. We used to think that the absolute limit for photosynthesis was light at a wavelength of about 700 nanometers. But the Carlsbad microbes? They proved that life can use light all the way up to 780 nanometers. That might not sound like a huge jump, but in terms of the energy available for life to use, it's a massive expansion. So what's the bottom line here? It means that all those planets orbiting all those super common red dwarf stars, planets that we might have written off before as being too dark or getting the wrong kind of light,
Well, they are now prime real estate in the search for life. The game has totally changed.
And this isn't just some fun thought experiment. This discovery gives astronomers a brand new, concrete roadmap for how to hunt for alien oxygen, especially using incredible tools like the James Webb Space Telescope.
And the new search strategy is actually pretty straightforward. Step 1, keep studying these microbes right here on Earth to figure out the absolute bare minimum light they need to survive. Step 2, use that information to pinpoint the best possible exoplanet targets orbiting those red dwarf stars. Step 3, aim our best telescopes, like the JWST, right at them. And Step 4, scan their atmospheres for the telltale signs of life.
And this is what makes the search so much smarter. It's like going from searching for a needle in a haystack the size of a galaxy to just searching in one corner of the barn. Instead of having to guess between 100 billion stars, this new understanding helps scientists zero in on maybe the top 50 most promising candidates. It's all about focusing our energy where we have the best shot.
So what are they looking for exactly? What's that chemical fingerprint? Well, the holy grail is oxygen. As Hazel Barden points out, it's really, really hard to get a planet's atmosphere filled with oxygen unless you have life constantly pumping it out, just like plants do here. So if we find it on one of these exoplanets, yeah, that would be a very strong sign that we've found something.
And that brings us back to our final question. Who would have thought that the key to finding life out there in the universe might be hidden right here in the darkest places on Earth? It's just incredible. A journey that starts in a pitch-black cave has given us a whole new map for exploring the cosmos. It really makes you wonder, what other massive secrets are just waiting to be discovered in the shadows of our own world?